Yeah. I mean, there's only one section after this.
So when's the test?
But it is Tuesday, so
Yeah, well, the test will be Monday no matter how far we get.
you'll all be gone.
Okay, I'm not gonna, I mean, like, I'm
Oh,
not
wait.
changing things around for that. My guess is we'll just have 1 day of review. But we would be far enough by that point,
Okay.
yes. So we'll finish 3-4 today. And then 3-5 should only take 2 days. Honestly, I'm going to kind of leave it up to you guys. So 3-5 is only one topic. It's inverse trig derivatives. It's just using formulas. So, like, the topic itself sounds horrible and the formulas don't look great, but all you're doing is using a formula. So, I didn't know if you guys would prefer trying to, like, rush through 3-5 in 1 day and then having 2 days of review, or if you would rather me do 3-5 over a course of 2 days and have 1 day of review. I'm open to whatever. I mean, like, we could easily do either one. But the goal is to take the test Monday regardless, so that if anybody's gone Tuesday for whatever reason, that won't really affect things. The test would be ready by Friday if that's what you're wanting to do too. Worst case scenario, you could always take a test when you come back from break. I mean, I don't know. It only matters if you're going to be gone. So if you're going to be here, it won't matter at all. Do you guys have a preference what you want to do, or do you want to just wait and see how 3-5 goes before you decide that?
Is there a formula sheet on the test?
Say it again?
You have a formula sheet on the test?
Haven't decided that yet.
Like these parts, cosine, themselves?
Good chance you will, but I'll talk to Mr. Stouffer so that we decide whatever we're going to do. Because yes, I mean, like, those formulas would be difficult to memorize in a course of like a day, and I would get that.
Will we get them on the actual AP test?
Nope. The actual AP test, they give you 0 formulas for anything, and there's an awful lot of formulas by then to remember. And to me, that's one thing that makes the test very difficult. I think quite a few people would do quite a bit better if you were given formulas, but I know that that's part of their grading, is that they want to see how much you can do on your own without assistance. So it's been a while since we did this. So this was last Thursday. I don't know how much of this you remember. Do you want me to kind of start from the beginning on this problem to kind of re-explain what we were doing?
Yeah.
Okay, I can. This one was one where we needed to use the calculator. And we had gotten to the point where we needed the calculator and we ran out of time. But I will start from the beginning and kind of explain what we're doing. So if the function is 4x7 minus x squared plus x minus 5, it says find f inverse prime of 3. So that would be the derivative of the inverse at x equals 3. So that's kind of the 3 things we have to work with, that we have to kind of figure out how to work with, I guess. We do have a formula we can use. And the formula that we have is that the g represents the inverse. So this is going to be the inverse derivative at 3 can be found by doing 1 over the original function derivative evaluated at the inverse of 3. So that's kind of a lot to work with there. Really, the one main part you have to kind of remember how to do is the inverse at 3. So this is what we're trying to figure out. We're trying to find the inverse at 3 is equal to something. And if we kind of remember how inverse works, that's going to mean the regular function at some x value should equal 3. That's what the inverse at 3 means. So the x's and y's are reversed. That's why we have this written up here. We set the original function equal to 3, and then that's what we're trying to solve. Now, traditionally, if these are a non-calculator question, then the answer is always going to be 1, 2, or 3, or -1, -2, -3. It's going to be something that you should just be able to plug a number in very quickly and evaluate and find the answer. The equations won't be easy or solvable usually, but the answer itself works out nicely, like they're planned that way. But since this one was dedicated as a calculator question ahead of time, we just flat out know it's not going to work out right. There's different ways to solve on your calculator. The way that most people prefer is that you make the equation equal to 0. And so I subtracted 3 from both sides. Now, on Thursday, right about where we ended, I talked about the solver. Where's my calculator? There it is. The solver is not something that we'll ever use in calc. And I can't remember which science class uses it. I don't think it's physics. Is it? Oh, chemistry? Okay. So, yeah, I knew one of the science classes very heavily uses it. I believe that's in apps or something, isn't it?
It's in math at the very bottom.
Could be.
Yeah.
There you go. Now, the numeric solver generally works on polynomials. But part of the issue is, doesn't the solver only usually give one answer? I stopped using it a long time ago because it doesn't work well for math frequently. And I know where it has issues is if your function isn't a polynomial, it starts acting strange. So I traditionally don't use that. The most common way we're going to solve things, if we're using the 84, is we're going to put it in y equals. Now, if we were using the inspires, which we can start using soon since I have a class set, we haven't really gotten any problems that needed them. But if you have the inspires, you can just type it directly in and say solve, and it'll give you all the answers. That's one reason why they're not allowed on the ACT. What's the equation? I already forgot. So 4x7 minus x squared? Nope, my minus is in the wrong spot. Now, if I graph it, I honestly have no idea what my axes are set at. They're probably set at -10 to 10. I can change them around if I need to. My guess is it's just going to have this one answer. Theoretically, because it's a 7th powered equation, it could have 7 answers. It could cross 7 times, possibly. Usually it won't. Do you guys remember how the imaginary numbers go in pairs? That was supposed to be part of pre-calc. Okay, I see you remember it well. So there's a good chance this equation has one real solution and 6 imaginary solutions. And you could theoretically find out by like synthetic division and all this kind of stuff, but we're just going to use the calculator for this question. I want to know where it crosses right there. So I'm going to go to the calculation menu, which is above trace. So second trace. These are the different calculations you can do from the y equals menu. I'm trying to find the 0 because that's where it crosses the x-axis. And you'll see my cursor's blinking right there. I'm going to guess yours is going to be close, if nothing. Left bound is what it says at the bottom. What it wants you to do is put your cursor to the left of the x-intercept. So, sure, it's to the left of it. And then it wants a right bound, which means I'm going to hit to the right until my cursor moves to the right of the x-intercept, which is kind of difficult because this thing goes up so steep. I'm just going to click it there because I know it's off. Depending on which calculator you have, some of them put these little dotted lines in, some of them don't. And then guess means it wants you to put your cursor close to where it crosses. So we had to put bounds to start with so that the calculator knows what to look in between. And then you put the cursor close to where it crosses so that it knows approximately where it's trying to find answers. And what the calculator does is it makes a table in the background and just looks to see where your graph crosses from negative to positive. And then it just zooms in and keeps finding it until it gets as accurate as possible. Okay, so we've got an x-axis, or we've got a x-intercept right here, which is a solution. Before I go too far,
Solver got the same number.
yeah, solver, since there's only one solution and it's polynomial, I kind of assumed the solver would work okay for this one. You're definitely going to get really weird equations this year that solver is overmatched for. Here, let me just minimize this, I guess. I purposely had us type this equation in because to me finding the 0 is slightly easier, but it doesn't technically matter. If I typed in this top one, what you would need to do is type the left-hand side in as y1 and the right-hand side in as y2, and you would have to graph them as two separate equations, and you want to find their equal by when they cross each other. So I purposely made it equal to 0 so that I could just type in one equation and find where it crosses the x-axis. But you can do it differently. I kind of got the impression you guys haven't used the calculator much at all for anything over the past couple of years. So you're not going to be super familiar with it. There it is. Definitely the one portion of the calculator you're going to use a lot on the AP test is how to find solutions. And this is generally the way that most people do it, is they usually use the graph. And if it's equal to 0, you look for an x-intercept. If you have two equations that are equal to each other, then you graph them separately and find where they cross. So, like, I absolutely could have done that on this one. I could have done 4x to the 7 minus x squared plus x Oh, shoot, it wasn't -8. What was it, 5? There we go. Okay, there we go. Yep. I suppose it's kind of hard to see because it's so steep. Where both of those cross should be the exact same x value as where the blue one cross the x-intercept. If I wanted to find where two equations cross, I still use the calculation menu, and then instead I would choose number 5 to find where two lines intersect. And it's going to give me similar instructions. First curve, I'm going to need to put it on the red ones. So I'll click on that one. Second curve, that one. And then guess you put it close to where they cross. Whoop, 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 whoop. So you absolutely, what you're going to need to do is you're going to need to get comfortable knowing how to solve things on the calculator. Maybe it wouldn't even be a terrible idea after you get done with your homework to just, like, you're going to be able to solve them by hand for majority of the homework today. And you could possibly just use your calculator to practice getting comfortable with that if you've got spare time. I'm going to pretend you guys have a lot of spare time. Okay, anyway, I don't know. Do you need me to go through that more or again? I don't know. That's why I said I'm not sure, since you guys are so uncomfortable with the calculator. Like, did you maybe write down steps on what you need to do in your notes or anything? So you're going to absolutely remember this perfectly tonight.
Yeah.
I see. This is fantastic. And I don't, yeah, there wasn't directions in the problem. Okay, well, we're not actually even done with the problem. We spent a lot of time just finding this x value. What was it again?
1.106 and a bunch of other numbers.
Give me the bunch of other numbers.
3959.
Okay, thank you. If you're using the calculator, go as accurate as you can every time. Okay, so G of 3 is 1.1063959. Okay. I don't have any space, so I'm just gonna. So 1 over f prime of 1.1063959. Then I would have to take derivative of f of x to find f prime. That part's not difficult because it's a polynomial. What's difficult and annoying is using the equation. So then I would have to plug in 1.1063959 into that equation to get an answer, and the final number answer for this entire thing would be 1 over that long decimal being plugged into the derivative. I'll probably stop there to save a slight bit of time. And you guys have the answer keys to all these, so you would be able to look up those final number answers if you want. All right. So we're almost 9 o'clock. Okay. I really have no idea why these are part of these notes. This should have been part of the other day, 3.3, I think it was. Technically, there's only 2 formulas here. If you look at the formulas that are listed, there's one listed with an X and one listed with a U. These are the only two formulas really. Because an x could be a u and then du is to 1. But if you guys still have your little formula cards that I gave you, I don't know, last week, these would be two of them that you'd want to add on to it. So this is when you're trying to take the derivative of a base other than e, so like 2 to some power. And this is also when you're trying to take the derivative of a log with a base other than e. They're not any more difficult to do, they're just more annoying because they have extra numbers. It's just, that's the hard part, is remembering all the parts. So having a formula card for right now would help. We have a PLC meeting tomorrow to have to meet with our other department people, so I will talk to Mr. Stover tomorrow about a formula card to see what we'll do for this test. So if I try to compare it to the one you already knew, you knew e to the u. The derivative of e to the u is e to the u times u prime. And I realize that looks like a y, we'll just go with it. They technically are the same formula. ln of e would theoretically go first, but ln of e is 1. So it doesn't ever show up. So they kind of are the same thing. And then likewise down here, the derivative of ln of u is what we learned, and that was 1 over u times u prime. You also have ln of e as part of that formula, but that is also 1, so that it just doesn't show up. So these are the same formulas we've done. There's just extra parts to them when you're using numbers that aren't a base e. So, I don't know. I'm going to skip A, go right to B. I'm doing y equals 4 to the 3 to the x. 4 to the power of 3x. If I'm looking to find the derivative, A is 4. 3x is u. So I can match it up to that formula. So the answer is going to be ln of the base, so ln of 4, times a to the u is the exact same thing you started with. So 4 to the power of 3x is part of the derivative, and then times the derivative of the power, which would be 3. So if this was e to the u, we would just rewrite e to the u and then take the derivative of u. It's similar here, except you also have to take ln of the base multiplier. And it doesn't affect things much at all because ln of 4 and 3 are regular number multipliers. So if you had to take the derivative again, it doesn't affect it at all. I don't know, however,
Did you just leave that as the final answer?
that's your final answer.
Okay.
There's nothing more you can really do.
Yeah.
Yeah,
And these are just standard derivatives, not like inverse derivatives.
correct, which I don't, that's why to me it's confusing why they're in this section. Nothing to do with inverse. This would have made a lot more sense when we were doing the derivatives of e to the u and ln of u. And honestly, I'd kind of forgotten about them, just because we were so focused on e and ln that I had forgotten that we have to do it for all bases. Otherwise, I might have done the notes slightly out of order just to keep them together. But whatever. Do you guys want to try D? See if you can find D on your own real quick. The rest of these notes actually doesn't take long. It's just. I'm going to guess you guys are getting more comfortable with using formulas. Purva, you ready to help us? Excellent.
Ln of
Good.
5 to the 3 minus x squared.
Perfect.
Plus negative 2x.
Perfect. Once you figure out the pattern, there's really not much different to do. Good. Now the log-based one, I can explain one of these if you want. I don't know if it'd make it more confusing or not. Do you guys remember doing change of base? Like log base 2 of 8?
Kind of.
Yeah. So this is what you had to do before if you had a calculator that wasn't new. Because the new calculators allow you to type in any base. On your calculator, you had to change it to ln of 8 divided by ln of 2. Or maybe you guys used the log base 10 button. It actually didn't matter which button you used. You could use log of 8 over log of 2, or you could use ln of 8 over ln of 2. But like that was called the change of base formula. If we did that to this problem, and we wouldn't, I'm just showing you how it would work. If we did that to this problem, we could write it as ln of x divided by ln of 5. ln of 5 is just a number, so I could write it as 1 over ln of 5 times ln of x. And then if I did the derivative, 1 over ln of 5 is a numeric multiplier, so the derivative still has it. And then I do the derivative of ln of x, which is 1 over x times x prime, which is 1. This is going to be the same as the formula. So I'll erase it. I don't know what would be easier for you. I'm assuming you guys like formulas and kind of just matching them up. That's what it seems like you've done so far this year. Maybe I should go to... No, I'll stick with the easier one for now. Derivative of log of any base is 1 over ln of the base times u times the derivative of u. So they're not difficult to use. They're just weird formulas. Like that's by far the hardest part to remember. Let's go to a hard one. Let's go to B. Apurva, why don't you pick the next person? Boyraz?
Alright, so we got 1 over ln of 3
Good,
times sine of x,
good. Kind of weird, but correct.
and then like multiplying like the entire fraction, not just the bottom, I guess,
Correct?
by cosine of x
Correct.
times, I mean, I guess that's this one, so.
Oh, yeah, we'd stop there, yep. It is definitely a strange problem because sine of x is an odd information to have inside the logarithm, but it's 1 over ln of the base times u prime. I don't know, D's probably the hardest one. Do you want to see if you can do D? There's actually multiple ways you can do D though as well. So, like, pick your own way is fine. The answers are all equivalent. So this is what I meant when I said that there's different ways to do the problem. If you wanted to take the cube root out as a 1/3 multiplier from the start, you could have. You don't have to. I'll do the problem both ways for you. But as you do more logarithm problems, it's frequently a good idea to simplify them first because then they're easier to work with. Like a derivative on this one is much easier just because a 1/3 multiplier automatically goes to the derivative. So that derivative is quicker, but it's equivalent to leaving in cube root. Oh. Okay, the reason they end up being equivalent, like this derivative clearly looks worse, but the reason they're equivalent is this 1/3 would be a 3 on the bottom, or a 1/3 multiplier. The 2x plus 1 to the negative 2/3 power would move to the denominator as a positive 2/3 power and combine with the 1/3 power right here and make 2x plus 1 to the first power, which is right there. And then this 2 at the end was the 2 here. So my point is, it doesn't matter if you see different ways to do it. Answers should be the same. How comfortable did you guys feel using the formulas for these two kinds of problems? Pretty easy? So the reason I ask is because that's what 3-5 is. So 3-5 is using formulas. I don't know if you want to turn the page enough to look at them. Inverse trig sounds a lot scarier. But we're mainly focused on doing the derivatives of inverse trig functions. And the derivatives of inverse trig functions just mainly use the formulas. And so the derivatives themselves actually aren't that bad. So if you felt comfortable today, these formulas are traditionally considered harder to use than the inverse trig ones.
How would we do C if there's no like,
Base.
yeah,
So if you have a log with no base displayed, it's a 10.
Okay. So would we just write natural log of 10?
Yep.
Okay.
Yep. So that's the button on your calculator is log base 10. Do you guys know how to do the logarithms on the new ones? Where's my calculator? One. I don't even know if you'll need this, but still. You know how that we have those new menus that aren't displayed? If I do alpha F2, number 5 says log base. When you click that, it lets you type in any base. And so the newer TI calculators allow you to do that. The ones that haven't been updated don't. And I'm sure there's another place to get to this, but I've not looked for it. So, because I don't think it works when you hit that button. No, maybe it's under math.
Yeah.
Oh yeah. Okay. Okay. Either way, I don't even know if you'll need it for this one, but I figured I'd show it. I feel like that's probably enough. You guys probably want time to work on it more than like us going over a table again. I feel like you were decently comfortable with tables before. So why don't we stop there and you guys have about 15, 20 minutes to try looking at some of the problems, see if there's things you need help remembering.